Good morning, everyone. So today we are going to solve exact differential equation. So these are the formula that we will be using later on. So as we all know, it is said to be exact if the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. So if they are exact, we can now use this formula. So partial derivative of f with respect to x is equal to m as a function of x and y. And the partial derivative of f with respect to y is equal to n as a function of x and y. So we have a exact DE here. This is number 2, our number 2 problem. So let's transpose this one here. So y e raised to x minus sine x dx minus y squared, then this will become plus e raised to x dy. So we will now test if they are exact. So partial derivative of m with respect to y. So our m is y e x minus sine x. So derivative of y is 1. Then copy the ex. So sine x. So this is equal to 0. So minus 0. So e raised to x. Then partial derivative of our n. This is our n. So over dx. Our n is y squared plus e raised to x. So this will become 0. Then derivative of e raised to x is still e raised to x. So e raised to x. Therefore, they are exact. So we can now use the formula, which is the partial derivative of f with respect to x is equal to m as a function of x, y. So partial derivative of f over with respect to x is equals to, or m is equal to m. So our m is this one. So y e x negative sine x. So as you can see, we can now we will cross multiply our dx here. So partial derivative of f is equal now to y e raised to x minus sine x dx. So we can now perform integration. So integral of f df is f. So f is equal to, so we will put dy outside. So integral of ex is still, integral of ex is still e raised to x. So integral of sine x is integral of negative sine x is negative, integral of sine x is negative cos x. So, negative cos x. So, our f now is equal to y e raised to x. So, this will become negative, so positive cos x. So, next, so we have now the f. So, our f is equal to y e raised to x plus cos x plus q of y. So, we are looking for the value of our y. So, the next is we will derive. So, partial derivative of f with respect to y. So, we will use our f. So, our f is y e raised to x plus cos x plus q of y. So, derivative of x is 1. Then, we will just copy the e raised to x. Then, cos x will be 0 plus q of y. So, this will be e raised to x plus q of y. So, now we can input our n. So, our n is, so this is equal to y squared minus, this is negative because transpose. So, negative y squared plus e raised to x. Because, so negative y squared plus e raised to x. That is our n, right? Because transpose. So, we can now cancel the ex. So, our q of y now is equal to negative y squared. So, let's integrate this one. So, this is in terms of dy. So, integral of q of y is y. So, our y is equal to integral of negative y squared is negative y cubed over 3. So, the value of our y is y cubed over 3. So, our f now is equal to y e raised to x plus cos x plus, negative, minus. Is minus because our y is negative y 3 over 3. So, we can simplify this answer by multiplying both sides to 3. So, our f now is equal to 3y e raised to x plus 3 cos x minus y cubed. And that is our final answer. This is our final answer. 3y e raised to x plus 3 cos x minus y raised to 3. It's not completed. So, y3.